Alright, 7th grade pre-AP, let's get started solving equations. This is the only part of algebra you'll really have. We're doing one-step equations all in one day. So let's try it out. Definitions first. What is an equation? Something that equals something. That's why it says equation. It equals something. Basically, if you take the shun off and put an L, it spells equal. So, here's a definition. Is a mathematical statement that two expressions are equal. You should know what an expression is. Remember, we did the quiz over this. So let's write a couple expressions. 3 plus x and 2x. This one is an expression because you're connecting a number and a variable with an addition sign. This one's an expression because you're connecting a number and a variable with multiplication sign. See, these are both expressions. Now, for them to be an equation, all you have to do is make them equal to each other. But what that tells us is that x has to be a certain value to make this equal. And that certain value... Okay, I believe this is where I stopped before the bell rang. So if I didn't, I'll review it real fast. Equation is two expressions that are equal. Or are two expressions that are equal. Solution to an equation is the value which make those equations equal. So like down here when we have x plus 5 equals 10. 5 plus 5 equals 10, so the value that's a solution is right there. Alright, here's the inverse operations. When you have plus, you have minus, minus, plus, times, divide, divide, times. You should know those, but that's what I'm talking about when I say inverse operation in class. When we're solving these equations, remember, opposite PEMDAS. If you ever forget what you're doing or you're in doubt, use opposite PEMDAS to solve these equations. The reason why is because you use PEMDAS to put them together, so why not use opposite PEMDAS to take them apart? Now, it's not always the easiest way, but most of the time it is, and if you're ever in doubt, you can always use it for a safety. So that means we're going to add and subtract first, multiply and divide second, exponents next, and last parentheses. It's kind of weird. So let's go on. Adding. So the whole idea behind this is we want to find the solution to the equations. So we want to find out what x is. We already know that x is equal to 10 in this. Whoa, not 10. Maybe we don't all know. But now x is equal to 6. 6 plus 4 equals 10. But that's not the point of this. I'm making these easy because I want you to see the process behind them. Because let's say we didn't have x plus 4. Let's say we had 2x plus 4 equals negative 10. Then it would be a little bit harder to figure out. So you have to know the process in order to figure that one out. That's called a two-step equation because it has two different operations, multiplying and adding. We're only doing one step right now though. So x plus 4 equals 10. Now I'm going to draw a line through the equal sign. The reason why I'm drawing a line through the equal sign, and I'll go over here to show you. Let's say 2 equals 2. Draw a line through there. If I add 1 to 2, I get 3. Well, 3 does not equal 2, so I know that I have to add 1 to this side to get 3. If I divide this side by 2, and I get 1 and 1/2, that doesn't equal 3. I have to divide this side by 2, and I get 1 and 1/2. So the reason why I draw a line through the equal sign is because I know that if I do something to one side of the equal sign, I have to do it to the opposite side of the equal sign. And the reason why is because it keeps it equal. If I don't, then it's not going to be equal anymore and it's going to change the whole problem. Alright, back over here. X plus 4 equals 10. I want x by itself. So in order to get x by itself, what I'm going to do is I'm going to use opposite operations on that 4 to get it to go away. It's plus 4, so I'm going to minus 4. 4 minus 4 is 0. Cancels out. So you end up getting x plus 0 equals, well, whatever I do to the left side, I have to do to the right side. So 10 minus 4 is 6. Now, x plus 0 is the identity problem. In other words, what that's saying is that when I add something to 0, I get that something back. So really, 0 doesn't do anything. So I can erase it. So I end up getting just x equals 6, which is the answer. So let's check it out, see if it is. We plug it back into right here. So we do 6 plus 4 equals 10. Well, 6 plus 4 equals 10, so we're good. Worked out. Always check it. You should always make 100 on these because you can check them every time. Let's go to the next one. All right, here's my x plus 3, so I'm going to subtract 3 from both sides. 3 minus 3 is 0, cancels out. I get x equals negative 7. Let's check it out to make sure it works. Negative 7 plus 3 equals negative 4. See how I plug that in right there? Because it does, we're good. Subtracting. Subtracting is just like adding. The only difference is its inverse is adding. So what you're going to do is you're going to set it up just like before. And instead of subtracting 5, I'm going to add 5 because negative 5 plus 5 is 0. Goes away. Now you get x equals 8. Now did I do that right? I didn't. What did I forget? That's right, I forgot. Then I'm supposed to do the same thing to the other side. I have to add 5 to this side. And I get 13. Let's check it out. 13 minus 5 equals 8. It checks out, so we're good. Now on the bottom one, it's kind of a tricky. It's not really a subtracting one. Because what happens when you have double negatives? That's right, it becomes a positive. So I'm going to erase all of this and make it into a positive. So now when I set it up and I do opposite operation, I subtract 2 instead of adding, because 2 positive and 2 negatives make 0. So I'm left with x equals, subtract 2 on this side, negative 12. Negative 12 plus 2 is negative 10. Checks out. Now multiplying. Multiplying is pretty easy. Basically because you're just dividing afterwards. It's actually easier in my opinion than adding and subtracting. So let's draw our line first. To get rid of 2 times x, what's the inverse operation of times? It's divide. So I'm going to divide by 2. Now this becomes a fraction. It's 2x over 2. Can I reduce it? Is there a number on the bottom that goes into a number on the top? Yeah, 2. 2 goes into 2 one time. 2 goes into 2 one time. So you see how we're left with just x on top? And that's what we're going for when we want to get that x by itself. But whatever I do to the left side, I have to do to the right side. 10 divided by 2 is 5. Let's try it out. 2, instead of x, I'm going to put a 5, equals 10. 2 times 5 equals 10, and it checks out. Let's try this one down here. Divide this side by 3, this side by 3. Those cross out, because 3 divided by 3 is 1. We get x equals 16 over 3. Now, if you were in algebra, I would say leave it right there. But you're not, so you have to change it back into a mixed number. How you do that? You do 16 divided by 3. 3 will go into 16 5 times with a remainder of 1. So it's 5 1/3. That's it. All right, dividing. Opposite dividing is multiplying. So this time we're going to be multiplying. So draw my line. And I'm going to multiply by 2. Now I have to do 2 over 1 because it's like a fraction. Top times top, bottom times bottom. If I did that, I would get 2x over 2. And just like before, when you have 2 over 2 and you reduce this, you're left with just x. So we get x over here. And whatever I do to this side, I have to do to this side. So I'm going to multiply by 2 over here. I get 8. Let's look at it over here. 8 divided by 2 equals 4. We're good. Now down here is just another way of writing the top part. Instead of saying x divided by 2, we're saying a half of x, which is the same thing. When it comes to fractions, what you do is you do the reciprocal. Because if you remember earlier this year, we talked about reciprocals. A fraction and its reciprocal, or a number and its reciprocal, when multiplied together make, 1. So we want it to become 1 because it becomes the identity problem again. X times 1 is x. So I'm going to multiply this side by 2 over 1, and I'll get 2 over 2, which turns into a 1x. If I do that to that side, I do it to this side, and I get x is equal to 8, just like over here. All right, here's some more fractions. Just like before, we're going to flip this one upside down. Because what's 2 times 3? 6. 3 times 2 is 6. 6 over 6 is 1. So these cross out, you're left with x. I have to do the same thing to the 12. I have to multiply it by 2/3. So I'm going to have to add my 1. First thing I'm going to do is I'm going to reduce this side. It won't reduce. So now I'm going to reduce this side. It won't reduce. So now I'm going to see if this will reduce. It will, by 3. 3 goes into 3 one time. 3 goes into 12 4 times. Nothing else will reduce on top or bottom. So you go 4 times 2 is 8 over 1, which is x equals 8. Now let's try this one down here. This is basically the same as the one on top. It's just saying 3 times x divided by 2. Well, same thing as doing opposite operation with the 2, which is times, and opposite operation with the 3, which is divide on both sides. And you get the same thing. X equals 8. That's it. Write your questions down if you have any questions, and I'll see you tomorrow.